Hi, we're going to evaluate the integral, the definite integral, over the interval 0 to pi over 6 of square root of 1 plus cosine 2x dx. So let's get started. The first thing I'm going to do to make this a little easier is use a substitution for my double angle. And I'm going to write it as this one. And the reason I want to do that is to get rid of the 1. So if I just rewrite this, I can write this as 1 and make the substitution of 2 cosine squared x minus 1 dx. Now what happens is the 1's cancel. So what you have left is the square root of 2 cosine squared of x dx. Now I can break this up and bring out the square root of 2, and then we still have the square root of cosine squared x. So I can bring this square root of 2 out and bring it out front. It's just a constant, 1.41-ish. All right, and then we have the square root of cosine squared is the absolute value of cosine x dx. However, since we're going from 0 to pi over 6, we know that cosine x is positive in that interval, namely it's in quadrant 1, so that means it's positive, so we can get rid of the absolute value sign. So basically what we have is square root of 2, and then we have pi divided by 6, 0, and we could take away the absolute value sign. All right, now let's integrate. So we're going to have our square root of 2. The antiderivative of cosine of x is sine x. And then we're evaluating from 0 to pi divided by 6. So that's going to give us square root of 2 times sine of pi divided by 6 minus sine of 0. So we know that's 0, and sine of 0 is just 0, and sine of pi over 6 is 1/2. So our final answer is just going to be square root of 2 divided by 2, or you can write it 1/2 times the square root of 2. And that's it. Thank you. Have a nice day. Bye-bye.